Take the derivative of y with respect to x. The derivative of natural log is 1 over the function, so that's going to be 1 over secant x. Then times the derivative of the inside function, so the derivative of secant is secant x tangent x. Simplifying dy dx, you'll get tangent of x. So the length of the curve is equal to the integral from 0 to b, square root 1 plus dy dx squared, so tangent x squared, dx. So the length of the curve is the integral from 0 to b, square root of secant squared x dx. Because from your identities, tangent squared of x plus 1 is equal to secant squared. So then the integral from 0 to b of secant x dx is the length of the curve. So to find the length of the curve, we need dy dx, which is equal to 3x squared. The length of the curve is equal to the integral from 0 to 2 of the square root of 1 plus dy dx squared, so 3x squared squared. Then simplifying the problem to get the integral from 0 to 2 square root of 1 plus 9x to the 4th dx to represent the length of the curve. To find the length of the arc, we need dy dx, which is equal to x to the 1/2. So the length of that arc is equal to the integral from 0 to 3 of the square root of 1 plus dy dx squared, so x to the 1/2 squared. Simplifying the problem, we get the integral from 0 to 3, the square root of 1 plus x dx. Then using u substitution, changing the numbers, get the integral from 1 to 4 of u to the 1/2 du. Anti-deriving to get 2/3 u to the 3/2 from 1 to 4. Then following the fundamental theorem of calculus, replacing in the value of 4, subtract replacing in the value of 1. And then simplifying our problem to get the answer of 14/3. So they give the length of the curve as the integral from 1 to 4 of the square root of 1 plus 9x to the 4th, rewriting that as 1 plus 3x squared quantity squared dx. So then you can see that 3x squared is representing dy dx. So dy dx is equal to 3x squared. Bringing dx to the other side, we have dy is equal to 3x squared dx. Anti-deriving both sides, we get y is equal to x to the 3rd plus c. Replacing in the given value of the point 1, 6. So y is equal to 6, x is equal to 1. Solving for c, we get c is equal to 5. So the equation is y is equal to x to the 3rd plus 5. We want to find the length of the curve. From 0 to 3. So we get the integral from 0 to 3 of the square root of 1 plus dy dx quantity squared. So we need to get dy dx. Taking the derivative of y with respect to x is 3/2 x to the 1/2. So the length of the curve is the integral from 0 to 3 of the square root of 1 plus 3/2 x to the 1/2 quantity squared. Simplifying the problem to get the integral from 0 to 3, square root of 1 plus 9/4 x. And by using u substitution, get 4/9 du is equal to dx. And the values of u are now 1 and 31/4. So the integral is equal to 4/9 from 1 to 31/4 u to the 1/2 du. Anti-deriving to get 4/9 times 2/3 u to the 3/2 from 1 to 31/4. Following the fundamental theorem of calculus, simplifying the coefficient, we get 8 over 27, 31 to the 31/4 to the 3/2 minus 1. To find the exact length of the curve, we need the derivative with respect to x, which is x to the 1/3 minus 1/4 x to the negative 1/3. So the length of the curve is equal to the integral from 1 to 8 of the square root of 1 plus dy dx squared. Since it's a calculator question, we can just type that value into our calculator. We get the answer of 12.375. So in this problem, we're looking for the perimeter. We have a function sine of pi x, another function x to the third minus 4x. Taking the derivative of sine, we get pi cosine of pi x by chain rule. Taking the derivative of the other function, get dy dx is equal to 3x squared minus 4. So to get the length of the curve for sine of pi x, that length is the integral from 0 to 2 of the square root of 1 plus pi cosine of pi x quantity squared dx, using the calculator to get 4.1610. Then to get the length of the curve of the other function, x to the third minus 4x, doing the integral from 0 to 2, the square root of 1 plus 3x squared minus 4 quantity squared. Again, using the calculator to get 6.634. And then to calculate the perimeter, just adding up those two lengths of the curves to get the final answer of 11.244.